Strobing and stretch. So a fundamental requirement for realism in animation is the psychological effect of the perception of motion. So this illusion occurs when the brain interprets a sequence of images as being the apparent motion of an object. This is also called beta movement. Now, sometimes this psychological effect, which is essential for animation to be possible, is called persistence of vision. That persistence of vision is actually a different optical psychological phenomenon. So now, when the action is slow and the sequence of images for an object are not so different from in position from frame to frame, then it's rather easy to maintain the perception of motion. On the other hand, when the action is very fast, then the perception of motion can be lost, because instead of interpreting the sequence of drawings as being the same object at different places, the brain can imagine that the object has disappeared and a new object has reappeared someplace else. So this disruption of the perception of motion in animation is called strobing. So here we see some simple ball bounce animations. The one on the right has a relatively smooth motion, and we maintain the perception of motion of a bouncing ball. The one on the left, there's some gaps, and because of that gap, it almost seems like the ball sort of appears at the bottom, and then appears near the top, and then appears near the bottom. Now, if you're trying to check your animations for this strobing, it's somewhat helpful to watch the animation in your peripheral vision. Then in the peripheral vision, your brain is exceptionally attuned to observing motion. That's actually a good tip in general for checking your animation. Now, another way of seeing this disruption of the perception of motion is if you're in some place where there's strobe lights, and so you have flashing lights, maybe at 10, 20 flashes per second, or maybe even higher. Then if you quickly move around, say flail your arms around, then you won't actually perceive your arms as moving. It just appears as if they are multiple images. So this is just another example of the disruption of the perception of motion. In this case, the strobe light takes the role of the frame rate in animation. Now, a similar effect occurs when we have the wagon wheel illusion. So in the wagon wheel illusion, we see a wheel on a car, and the spinning of the wheel appears to be backwards from what we know must be the direction of the spinning, given the direction that the car or the stagecoach is traveling. So so this is again a disruption of the perception of motion, but in this case the motion appears to be backwards from what we know must be must be the true motion. So here's a video that illustrates this. This is a propeller on an airplane, and the propeller is spinning faster and faster, and yet it appears that the propeller seems to come to a stop and then turn one direction, then turn the other direction, then come to a stop. But the propeller is not changing the direction that it's turning. It's always turning in the same direction, and in fact it's going faster and faster. But due to the frame rate of the camera, sometimes we're synchronized with the propeller, sometimes we're ahead, sometimes we're behind. So this wagon wheel illusion is an example of what's known as the Nyquist effect. So in this case, if we imagine like a stagecoach wheel that's turning, and on the first frame we have it here, this yellow colored wheel, and then on the next frame it's positioned where the blue wheel is. So the actual rotation is counterclockwise, but due to the Nyquist effect, we have the illusion that it's turning clockwise. And the reason is that the brain doesn't interpret the motion as being this spoke actually turning counterclockwise to this position. Instead, it imagines that this center spoke has rotated backwards and is now positioned here. The problem is that the brain misinterprets this because what it imagines is this spoke is actually this spoke over here that has turned to this position. In other words, the brain is misinterpreting which spoke it's seeing, and because it imagines that the nearest spoke on the next frame must be the one that it's seeing, it sees the wheel turning the wrong way. Now, because this effect of strobing is usually undesirable in animation, there's various ways of approaching it. And one thing which is used in animation because of this effect is motion blur. So when we have motion blur, it helps us maintain this perception of motion. Then there's also the effect of visually stretching an object. So this effect of motion blur, we tend to see the object as being apparently larger due to the blur. Now, this change is not an actual physical stretching of an object when it's falling. So, in other words, the falling objects do not get stretched by the force of gravity. In fact, something like a raindrop, as it's falling, if it's large enough, it actually gets squashed due to the pressure resulting from air resistance. So, in animation, especially in traditional hand-drawn, but even in CG and stop motion, stretch is used when the action is quick in order to reduce this unwanted strobing. So, and the reason that stretch helps is that it helps to guide the brain as to what it's seeing by minimizing the gap between the positions from frame to frame. So here we see an object that is slowing out towards screen right, And with stretch, we have much smaller blank spaces than we would have if we had the same slowing out without stretch. So now the use of stretch has been extended, and in fact it's useful for certain stylized forms of animation, sometimes called smear. So let's look at a short sequence from a classic example of smear.
Enemy of the Dover boys squanders his misspent life.
So watch carefully
The Dover boys.
in these
Them
quick
double-tracked.
actions.
They are escorting Dora Standpipe. Dear rich Dora Standpipe, how I love her. Oh, there's money.
Now some of those are rather obvious stretches.
Dover boys! Oh, how I hate them! I hate Tom! I hate Dick! And I hate Larry! They drive me to drink!
Now watch the bottle and the hands.
Found them.
So if you go frame by frame, it's impressive how the animators stretched and smeared the images, extreme distortions. Look at the mouth of the bottle and the bartender's hands, and when you're watching it, it's interestingly stylized, but you're not aware of it until it's pointed out. So anyway, very successful, effective use of stretch to control strobing and even to add a nice style. So in summary, strobing is the disruption of the perception of motion for a sequence of images. The Nyquist effect produces a false perception of motion due to similar duplicate images. That was the wagon wheel illusion. And then to minimize the effects of strobing, we have motion blur and stretch, and these can be even extended to create interesting stylistic effects in animation. So stretch is something that we'll see again when we talk about squash and stretch with forces in some of the future tutorials. So see you then.